Accuracy. On this lesson, we'll be talking about accuracy, precision, and how far to go out in your unit. So we're talking about significant digits and scientific notation, but they all kind of go into the same idea. So precision is the smallest unit in which whatever you're using, a ruler, a scale, whatever it is, has been divided. So is it counting, is the smallest unit of measure eighths, sixteenths, whatever it may be. So let's say that your ruler is divided into eighths. That means that you have an accuracy, oops, that's not supposed to have a T there. Is a half of that precision. So your accuracy would be 1/16, because half of 1/8 is 1/16. Basically, you multiply the bottom number by 2. Tolerance is your greatest acceptable error. So it usually is written as a plus or minus sign of whatever the unit is. So let's say 100th. And so let's say you needed to have a quarter with an acceptable error of 1,000th. That means that this would be okay all the way so in other words, we need to be pretty accurate. We do have a little bit of wiggle room. And so the tolerance amount will be listed like this, but it'll translate into numbers like this. And I'll ask you to identify your low and your high. So let's take this ruler. We have a 16th inch ruler on our divisions. We're going to use it to cut up a board that's 17 and 7/64 inches long. So that's how much we're wanting to cut from a 24-inch board. So that is enough room for us to cut that piece of wood out. What is the precision of our ruler? Well, remember, precision is the smallest unit which it can be divided. So our ruler is divided into 16ths. So our precision is 1/16. So now, we need to take and see how long can we cut our board according to our measurements. And so we don't have a way of cutting 64ths. We can cut 16ths. And so what we need to do is try to figure out 7/64, what is it close to if I wanted to make it into 16ths? And so I need to think about, what do I need to multiply 16 by to get to 64? And so if I want to get 16 to 64, I need to multiply it times 4, right? And so basically, my board is divided into 4/64 is what my ruler can cut. So how many 4/64 are in here? We have 4/64 plus 3/64, right? So that's going to be 1/16. This is close to another 16th. So 2/16, which is 1/8. So the length that we can cut our board, that tells us our partial amount. It's 17 and 1/8. So our answer is 17 1/8 because that's the closest I can get to that 3/64 that's left. So what is the accuracy of my measure? I take that 1/16 and multiply it by a half, which is 1/32. So what you're doing when you're trying to figure out what you can actually cut your measurement to is you are going to round this to the nearest 16th. So significant digits are the next thing that we need to worry about. This is something that you'll see in science and you'll see in anything that deals with numbers in this situation. The numbers 1 through 9 are automatically significant. The 0 is only significant in these situations. So like let's say I have 309. That 0 is significant. But if I have 300, then that 3 is the only thing significant. So if the 0 is between two numbers 1 through 9, then it's significant. This has 3 significant digits versus this one that has only 1 significant digit. Things that can happen though is they can take, okay, this is significant up to the first 2. They may tell you a certain number. And what that means is that we know that the accuracy is there. If we count it to the 9s, we know that this is accurate to that spot. When we do 300, was it an approximation of 300? And we counted out to where we knew that it was roughly 3 groups of 100? Or how was that found out? And so it usually deals with our standard error. And if this one is where the standard error is, then these two are significant. Biggest thing to note is, unless I state otherwise, the 0 does not count unless it's between 2 non-zeros. And scientific notation, that's where we did some things like 3 times 10 to the 6th. If I was looking to express, that was 3 with 6 zeros that followed it. I moved the decimal place 6 times that way. Or if it was really a small number, times 10 to the -6th. That means I moved the decimal place back this way 6 times. So there's a 1, 2, 3, 4, 5, 6. And then I usually put a 0 in front of it so I don't lose that number. So scientific notation is used to express extremely large or extremely small numbers. We'll often use these two things together because we'll identify the significant digits and then write it in that way. So now we are going to take and find the area output for this piston using the correct number of significant digits. So a piston it tells us this is a cylinder. And so the area we're talking about is that top area. So that's a circle. So the area of a circle is pi r squared. I had a lot of typos in this lesson. Sorry. And so if 2.5 is the diameter, our radius, remember, is halfway across. And so that means our radius is 1.25. And so we have pi, which is 3.14 times 1.25 squared. And so when we do that math, we come up with a number, and it's 104.2 90, and I wasn't thinking and closed out my calculator, 625. And so when we're trying to figure out what we're going to be using, we need to look at what our measurement was coming in. This has 2 significant digits. So that means I need 2 significant digits here. That means I'm going to round to this spot. That 0 tells the 9 to stay alone. So 4.9 inches squared is my area. Now let's go ahead and look and see what the force exerted to the correct number of significant digits. So what that means is we know that it's 1,800 pounds per square inch. And so I need to know what my pressure is. And multiply it times my area. As long as I'm in square inches here, I can use my PSI. And so we found out our pressure was my area was 4.9 inches squared. And this was our PSI. So when we multiply those two numbers together, we're going to take that 4.9 and we want to use that rounded number times the 1,800 and we come up with 8,020 is our force. That's a pressure that we are going to be exerting. And so my number of significant digits here is 2 as well. So this has 2 significant digits. So the least number I have is what you go with. So this one has 2 significant digits. This one has 2 significant digits. So that means I need to have 2 significant digits here. So that means I need to look at the 8. Does a 2 make me round? It makes me round down. So 8,080 is my pressure. The last thing we're going to be working with is really going to be working with the scientific notation. So how many plants are planted per acre? Well, he planted 28,500, but we're expecting a germination of 92%. And so we're going to multiply that times 92%, and that gives us 26,220. And my accuracy that I'm looking at is I have 3 significant digits here, 2 significant digits here. So I'm going to go down to 2 significant digits. That 2 tells a 6 to stay alone. So 26,000 is my number outside of scientific notation. Now, if we need to put it in a scientific notation, that means I need to put the decimal place after my first non-zero number. So 2.6. Now, how many places do I need to move it to get there? 1, 2, 3, 4. That tells you your exponent. Now, how many are expected in the 150 acres? Well, I'm going to take that 2.6 times 10 to the 4th and multiply it times 150. And what that means is I take 2.6 times 150 and I keep that times 10 to the 4th at the end. And so we get our calculator. We're going to do 2.6 times 150, and that gives us 390. 390 times 10 to the 4th. How many more decimal places do I need to move? 1, 2. So I need to add 2 here. That gives me 3.9 times 10 to the 6th. And that's the answer in the correct number of scientific notation and the correct number of significant digits.